Okay, next up, latch up, we have Darshini. Please make her welcome.
So hi, my name is Darshini Muttakumran. I am a first year at UCSD and I major in electrical engineering. I am presenting the slide. Basically, it's been a last minute call basically. So I'm presenting SVCK, which is a SystemVerilog checker, and this was developed by Himank, who is a student at Mission San Jose High School, and it's also done by Deepa Palaniappan at ASFIGO, as well as Balam Naik who is a semiconductor technologist, as well as Muthukumaran Vaidyanathan, who is also a semiconductor technologist. So let's move on, I guess. So what is a SystemVerilog? What is the lint tool for SystemVerilog code? So basically, this tool helps you find bugs early on. It also saves time and cost, and it keeps your code compatible with across tool chains, and it integrates easily with CI and CD. And this linter is needed for SystemVerilog RTL and TB, as well as UVM codebase, and assertions, acceleration, emulation, and formal verification. So what is SVCK? So it is basically an open source minimalist linter for SystemVerilog code. It focuses on enforcing consistent rules across your code basically. And there's this framework called BYOL, which is Build Your Own Linter, which is a framework for custom rule creation, so you can create your own rules within it for your code. So the built-in checks for SVCK includes naming conventions, encapsulation practices, line spacing and formatting, and general code hygiene. So why should we use SVCK? It is lightweight and easy to configure. It is extensible for project-specific linting needs, and it improves collaboration by enforcing shared code or shared coding standards. So how does this work with integration and workflow? So basically, you can integrate it within CI and CD pipelines. It basically helps you maintain clean, readable, and maintainable HCL code. And it basically encourages best practices. So it also helps you have a uniform code base. And let's say you have an already existing code base, basically, and you want to integrate it within your current code base. So how do you check for compatibility? Is through linter. So basically, you use linter to check whether the already existing code base is compatible with your current one, and then it basically tells you if it's not or not, where it's not compatible and how it won't be compatible, and it basically helps you for future check-ins. So why not just simple script? First of all, the linter tool that we have is robust and scalable by design. So basically, it is built on Google's open source Verible parser. So it's not ad-hoc regex or Perl scripts. And it provides professional grade parsing and has linting capabilities. And it ensures that your code is accurate and compatible across large complex SystemVerilog, as said before. And one specific thing about this tool is that you can customize it. So the modular architecture allows for an easy extension and rule customization. So as users, you can define the project-specific linting rules. This is ideal for both verification and design workflows. So some of the sample lint rules that we have in SVCK is basically encapsulation enforcement. So you can ensure that you're using a proper use of syntax, basically, so such as local, protected, virtual. And the naming conventions, so you can check whether your code is adhering to the consistent naming patterns across your code base, so for module, signals, and variables. It also ensures that your class is declared inside a package, and it doesn't allow you to do a nested class declaration. So this is an example that we have, which shows how the linter tool works on your code. So basically, let's say your code is missing a package. which is not consistent with like the SystemVerilog guidelines. So when it sees that, it flags like a violation in your log basically, and then it tells you whether you have an error or not. So this way you don't have to like go through your entire code and check for where your error is or not. And on the other hand, you can see how when you have the right code, you have followed the right guidelines, you can see how it doesn't show any error and it just runs smooth basically. So this is just SVCK architecture, where basically you have your SystemVerilog file. It goes in and then it checks like where your errors are. After that, through the import in any tree, so you can, it basically interprets the error. And then on your last part, this is where you implement the rules beforehand based on like what you need, what your code is. It checks for the selected rules and then it flags the errors basically. So it tells you where the rule violation has happened. This way it makes it easier for you. This is just like an example of like the code itself that was written for SVCK. So it basically just tells you, like, it doesn't tell you anything, but it's just like, it tells you like how the code was done for SVCK. So the function and like this function detects if a class is in the scope of a package or not. So it kind of just shows you like how the specific rule works. So moving on. It's just a summary. Basically, Build Your Own Linter, BYOL, presents exciting new frontiers. It is an open source, so basically you have like, it can like paves the pathway for commercial tools to follow. And basically it's just, I invite you to innovate. So what linters would you build on top basically? So thank you so much. If you have any questions, you can email me and I can redirect it to the contributors or authors, but I know my email's not here. It's just my first name dot last name at gmail.com. So I hope that was informational.
Cool, thank you. Any questions from the, oh no. Any questions? Yes, sorry.
So I want to ask if SVCK has a language service protocol support. Yeah, I mean, it's basically for the people who use Vim and trying to have a linter inside the code. I'm just wondering if SVCK have a language service protocol support.
I'm not sure. I'm just here to present.
Oh, sorry. Yeah. I can direct the question to the maintainer.
Yeah, I can do that.
Yeah, very cool. Did you help with the development of this at all?
I kind of just worked on the slides pretty much.
Okay, sure.
Yeah, that's why I got called in. Yeah.
Where did you guys hear about like Verible, and like how did you know to like start from there to build the linter?
Again, I need to redirect the question.
Okay, sure. Yeah, no worries.
Yeah.
Verible, it's useful like tool that I've used before, and I was wondering if you looked at multiple options before kind of settling on that. So anyways, yeah.
That's a great question. I can ask them for sure.
Is Verible considered like the state-of-the-art open source parser at the minute? Oh.
There's a very nice micro page with all of them compared.
Oh. And
Slang's doing very well.
Slang and micro have it covered though. Okay. Very good. Good to know.
I mean, it's a different kind of parser. It's a forgiving parser because you want it to parse incorrect or kind of partial code where you didn't finish the line. So it's kind of a different kind of parser than what Slang would do normally. What's that? Okay, Slang is becoming more forgiving. Very good. Good discussion. I think the other added to the language server protocol part, I think Tim can answer right away.
I wasn't going to answer that one. I was going to respond to the, there's a repo called SV-tests. If you have a SystemVerilog open source project, you should get your project added to the test suite, and the test suite will then run a whole bunch of different parsers against the all the tests in there. Some of them are very much basic tests that do various parts of the different SystemVerilog specification, and some of them are full, Black Parrot core and other things like this. And it's kind of based on, if you're old enough, you might remember these acid tests from CSS days. It's based on that type idea that if you give developers a giant grid with red X's on it, they will work to improve the X's until they're all green ticks. So, yeah, if you've got SystemVerilog stuff, go and put it in SV tests.
SV tests, very good. All right, we've got to leave it there.
Thank
Thank
you.
you, Darshini. Thanks for coming along today. Appreciate it.